Well, once again, welcome to this month's third Friday of the month radio show, Ask Your Herb Doctor. My name's Andrew Murray.
My name's Sarah Johannesson Murray.
For those of you who perhaps have never listened to the shows, they run every third Friday of the month from 7 till 8 p.m. We're both licensed medical herbalists who trained in England and graduated there with a degree in herbal medicine. We run a clinic in Garberville where we consult with clients about a wide range of conditions and recommend dietary supplements, nutritional counselling, and an alternative approach to the management of various different conditions. You're listening to Ask Your Herb Doctor on KMUD Garberville 91.1 FM, and from 7:30 until the end of the show at 8 o'clock, you're invited to call in either with questions related to or unrelated to tonight's topic of the metabolism of cancer. We're very pleased to have Dr. Ray Peat with us once more, and this month's topic is actually based on his newsletter. The newsletter he brought out back in May was another introduction to cancer metabolism, but if I remember rightly, the paranoia versus trustanoia was a interesting concept where most people trust mainstream medicine to do them right. Choose wisely and find your information out from alternative sources. I think that alternative word is another very good starting point for tonight's show. It is the drive that the radio show is having to basically keep running. Free speech radio and independent radio stations are really not very common in America anymore. Radio shows are generally getting taken over, becoming more and more mainstream. But obviously free speech is still alive, and again, that's our constitutional First Amendment right. So it's a very precious thing to have free speech aired on the airwaves, whether it's locally here or broad across the nation, on the internet or other radio stations that would carry this show. It's a very precious commodity. So you know that when free speech starts to become suppressed, you know the government are really not what you want in power. I will say no more about that, but the constitutional amendment, First Amendment, is a very strong and fundamental right that we all have as American citizens, to be able to freely choose what it is rather than be told that this is what you're going to get. So the Ask Your Herb Doctor show is definitely one of those radio programs that brings you an alternative to the mainstream narrative, what you're going to hear from the mainstream science and doctors. And Dr. Raymond Peat, fortunately, is a wealth of information, very alternative, definitely outside the box thinking, like so many of the great scientists that he quotes during his work, from St. Georgie to Gilbert Ling to May Wan Ho, and many, many others that we've mentioned over several years now, probably going on 8 years, that we've been delighted to have Dr. Peat sharing his wisdom with us.
And if you listen to commercial radio now and then, you know what media consolidation means. It's cookie cutter programming. And 15 to 20 minutes of every hour, they're hounding you to buy stuff. KMUD is different, completely different. And you know why? Because it's independent, community-based community radio, funded by the community, and our only responsibility is to you, the listener. So please support KMUD.
Okay, Dr. Peat, is Dr. Peat with us?
Yes.
Oh, hi, Dr. Peat.
Hi.
Well, thanks so much for joining us. I think what I wanted to do was just basically describe an outline of what has happened in science, and which has very much derailed some very good research that was done that perhaps didn't go along with the corporate collectivistic background controllers, if you like, from the Carnegie and Rockefeller foundations. I know a couple of months back we had the subject, and very much what was brought out was that the the institution has institutionalized medicine to the point where good science becomes largely ignored or demonized. I think that's very true to say, and it's not just scare tactics. It's very much true that alternative medical doctors get hounded out of medicine. They have to leave the country, go abroad where they can continue to practice, because in this country there is quite a powerful suppression of alternative ideas. So I think, without me probably carrying on too much more, I think just starting with Otto Warburg, if you would outline perhaps the history of oxidative metabolism, which Frederick Koch, through Otto Warburg and Albert Szent-Györgyi, elucidated, and how that really should have been the direction that medicine, if it really wanted to help people with cancer, should have gone in, but which, through various powerful lobbying groups and the estrogen industry, etc., have derailed it, and it's become very much a dogmatic, destructive, cidal type approach, like bactericides or viricides. It's a kind of cancer-ricidal approach to killing cancer cells with chemotherapy, radiotherapy, and all the other targeted programs that basically destroy the organism rather than help it. So would you be able to give an outline of metabolism as seen through the eyes of these great scientists who really were onto something?
Yeah, starting in 1900, the idea of electrons in molecules was really just being explored. It was about 1935 when mainstream chemists started accepting that there was such a thing as a free radical. But in 1900, Moses Gomberg at the University of Michigan had produced a stable free radical, which with a free but fairly unreactive electron produced a deep purple color with a very small amount of the molecule in solution. And this started other chemists thinking about what produces color in molecules. And over the next 4 or 5 years, several chemists were theorizing about mobile electrons in molecules like benzoquinone. And these were really at the center of mainstream chemistry, but even the average university chemist wasn't up to date on the theories of electrons. It was only in 1916 that Gilbert Lewis gave his theory of electron bonding, and then Niels Bohr, I think it was 1921, described his picture of how electrons orbit around molecules. And then several years later, Linus Pauling gave a more detailed description of how electrons work in chemical bonds. So the very best biochemists were just getting started around 1935 thinking about electrons. Mm-hmm. And biologists and medical doctors couldn't imagine how electrons could have anything to do with the life process. So the process that is involved in oxidation, it's the movement of electrons from a fuel such as sugar or fat to oxygen. And in the process, it's there's a lot of extractable energy in some form. And when the biologists finally admitted that electrons had to be explained somehow, they wanted to compartmentalize how the energy is used in moving from glucose or fat down to oxygen. And so they invented little machines that would take a sort of a quantum of of energy out of that moving electron and attach it to various little machines, which they called pumps or motors and so on, and explained muscle contraction and secretion and all processes in this very primitive concept of biological energy, where the actual process is a flow, a streaming process. There's no standing still for the electron. The cell dies if it isn't constantly moving the electrons from fuel to oxygen.
So this is a process that's going on every breath we take, and every single cell in our body is moving these electrons from sugar or fat to oxygen.
Yeah, and when you try to measure the electrical energy of a cell, you stick a needle in, for example, to measure the voltage, and people have a sort of a standing, static picture of the cell in which it's a membrane, and inside there are statistically randomized molecules carrying electrons, and so they think of it as effectively a bag of electrons which they're measuring. What they're doing is disrupting this intricate, constant flow from fuel to oxygen, and they're measuring an injured cell every time they try to stop it to fit their model. They're destroying some cell process. And in the 1940s, St. Georgi published some of his work with oxidative processes in muscle and how energy is used. And he was the one who discovered that ATP literally makes muscle contract. He extracted muscle and used various simplified preparations to show that simply adding ATP made the muscle move. And he was thinking of something electronic going on related to oxidation and fuel use and so on. But he found that the contracted muscle in the presence of ATP didn't break down the ATP molecule. That ATP causes muscle to contract without changing its bond structure.
Well, this is very interesting, folks. When you hear this, I don't want to interrupt you too much. So, muscle contraction can occur in the absence of the breakdown of ATP, which is not what I was taught when I was at school. So, anyway, yeah, most people that listen to what you've just said now might remember that the classic description is ATP is reduced to ADP and AMP, and that release of that phosphate group is what actually drives the muscle. But Dr. Peat, you're saying that is not the way it is.
Yeah, when I was in graduate school, the muscle biologists all over the world were saying that ATP has a high energy bond of 11 or 14 kilocalories per mole. And it's that energy that can be used to explain the little muscles, motors in the muscles that cause movement. Without that high energy, it would be impossible to explain their motors. But meanwhile, Gilbert Ling had, I think he probably read St. Georgi too, and was aware that ATP didn't have to break down to release energy. He pointed out that the energy of the whole molecule of ATP sticking to the protein of the muscle has an energy of stickiness or adsorption energy of 21 kilocalories per mole, twice as much as the hypothetical bond energy. And that explains why it makes the protein change without having to break down. Simply the relationship between the molecules shifts the whole structure.
Yeah. And this is very much that kind of holistic alternative approach to science and to biology that enables these people that are doing this to see the whole thing is confluent, and it's constant. Like you said, the electrons don't stop; they're constantly moving. They're constantly in action, and that is life right there. When molecules are being produced and cells are being signaled and communication is happening, it all involves energy. And I know you're a big advocate of supporting thyroid function, because that ultimately is a very big driver of metabolism, as is mitochondrial function
and the energy of the cell.
Yeah, and that all of this is we're all very much energetic living beings. We're not static, and actually a lot of what we'll perhaps get into later on here with cancer metabolism being a very aberrant form of that kind of metabolism, which is much more destructive and very negative, is very much opposed to regular life, which is productive and energetic, and that high energy state is what actually keeps us alive and healthy, and allows our immune systems to get on top of spontaneous cancers, because they know that they do arise all the time, and it's only in those lowered energetic states where people can actually produce a cancer that starts to take them out, and it's all the negative lactic acid production, etc., from tumours that contributes in the carbon monoxide. We'll get into that later on. But
we're not talking about like the high adrenaline, that type of energy. We're talking about energy from a cell functioning properly and having enough thyroid, which basically means the cell has enough oxygen, and it's a very calm state, but your cells have a lot of energy in that calm state.
All right, you're listening to Ask Care with Dr. KMUD Garberville 91.1 FM, and from 7:30 until the end of the show, callers are welcome to call in with questions either related to this month's topic of the metabolism of cancer, and a toll-free number if you live outside the area. There's an 800 number, which is 800 KMUD-RAD, so that's 800-568-3723, or if you're in the area code, the number's 923-3911.
Actually, Michael said that he didn't think
I thought that if you've been calling the show from Missouri, call whatever number you've been using. But I was under the impression the 800 number didn't work out of California, but I could be totally wrong.
I didn't know that. Thanks for telling me.
Anyway, I mean, we're broke and the 800 number isn't free. The 800 number costs us, so you might as well have it on your phone bill anyway.
All right, there you go. Okay, so, all right, somebody was going to come in at one point.
Well, no, we're going to do that at 7:25.
Oh, we're doing it at 7:25. Okay, all right. So, Dr. Peat, getting back to this kind of energetic state of the cell, that's probably a good point at which you understand how cancer can arise, how it can be allowed to be outside the body's normal control, and how that energetic state, we won't call it energetic, perhaps we call it excited, depleted state, should best be understood as a way to understand cancer.
In the 1920s, at the time Warburg was developing his idea of oxidation, a man in England, David Keilin, was working on another side of oxidation with these cytochromes, and he found that when an insect flight muscle or a bird flight muscle, a very energetic muscle, when it was contracting and highly stimulated, the pigment that he was studying disappeared, showing that there was no oxygen present. The extreme activity had consumed all of the oxygen momentarily and shifted the cell and those pigments into a reduced state of excess electrons. And so this was, St. Georgi and Keilin were simultaneously working on the ideas that William Frederick Koch at the University of Michigan had developed independently, that it's the flow of electrons through the system to oxygen, which has to be continuous, and when something overstimulates or irritates an area, the idea of irritation and or carcinogenic smoke and so on was already known, and the irritating effect of estrogen, for example, was already known. So the idea of excitation exhausting the tissue oxygen was at the center of the idea of what cancer is. Warburg described his thought at that time as the cancer has a defect in respiration, which makes it lack the Pasteur effect, which was what Pasteur had seen in yeast, was that oxygen normally causes the yeast to stop fermenting, to stop producing lactic acid or ethanol in the case of beer. But St. George said there's something wrong with the system that prevents cancer from, even in the presence of oxygen, from being able to turn off that excitatory process that produces lactic acid. So there's something keeping the cell in the excited state. And that's where the details have been developed now over the last 90 years since Warburg expressed that idea. What are the things that can turn off the excitation, the excess of stimulation, and let the oxygen, which can be present, let the oxygen do its work to turn off the lactic acid production.
So it's a form of energy production the body has as like a backup mechanism. When it's not using oxygen properly, then it converts to using sugar, and it's inefficient and it's wasteful and it overexcites the cell. Is that, I'm just trying to understand this myself and also put it into some a little bit more understandable terms for our listeners.
When it's either deficient in oxygen or overstimulated.
So that it used up all the oxygen because it was overstimulated.
Yeah, so it's the same thing as suffocating or being overstimulated. There's no oxygen to turn off the production of lactic acid. And then the lactic acid itself is an irritant, a stimulant. It shifts the cell away from the use of oxygen towards the production of more lactic acid.
So it's like a vicious cycle. Here, we're going to pause you for a moment here, Dr. Peat, while we have Jordan come in, and we're going to talk about what a wonderful radio station this is. It's an oasis of diversity, and it's an oasis amid the sameness of the commercial media landscapes. We provide essential nourishment for your mind and soul with our amazing variety of programs.
Wow, what a show tonight. Very scientific. No one like Dr. Peat.
No one.
He really gives you the info, but some real science tonight. You really got to pay attention.
Yep.
But I just want to thank you guys for coming in and doing your show every month. I want to thank all the talk show hosts, and I want you, dear listener, to thank the talk show hosts by calling in your support to 707-923-3911. We've got some phone answers out there who'd really like you to keep them busy. And I loved, Andrew, your opening remarks about the Bill of Rights, the First Amendment, and how if we don't use our rights, we lose our rights.
Absolutely. The government need to hear that from us.
Yeah, and your comment earlier out in the hall about that's what it's all about. This is free speech radio. There's 25 different viewpoints from 7 to 8 during the course of the month. Right. And it's part of our programming that includes you, and we just really want you folks who listen, and we know talk show listeners are pretty emphatic listeners and pretty dedicated listeners.
And I know there's people who listen from all across the country for this because they call in.
Right,
so,
yeah, absolutely. From the East Coast through the Midwest.
And if you don't call in even, that's okay. You can still donate. You can just call in at 707-923-3911 because this community radio station is not getting support from,
government.
Or from when you buy products.
Right,
some of your money is going to, and marketing budgets of major multinationals do not support KMUD.
Right. So
it's up to you.
Any amount, gratefully appreciated. Just write out check, money order, whatever you have. Send it to KMUD here in Garberville.
Yeah, it's Box 135 in
Box
Redway.
135, Redway,
And
California.
don't forget,
California 95560.
if you're listening online, KMUD.org, there is a way to donate right there while you're listening. Press the red button. A sustaining membership of $120 a year can be taken out $10 a month very painlessly, and it's a great way to support the Mud.
It's a great way to support your First Amendment too.
Yeah, well, because the free speech you're hearing today was paid for by people who donated during our last pledge drive.
Yeah.
Absolutely.
So I want to let you guys get back to Dr. Peat, and thanks for the show.
Thank you, Jordan.
You're welcome. Yeah, well, we appreciate KMUD for allowing the show Ask Your Abe Doctor to even happen. I think it was probably 12 years ago now. I know time flies so quickly, but I think it was 2004. Yeah, I think it was 2004 we did the first show. Here we are, 2016. Anyway, Dr. Peat, you're there, right?
Yep.
So you were telling us about lactic acid and how it feeds cancer cells and because of the lack of oxygen?
Yeah, anything that causes a lack of oxygen or excessive irritation and stimulating to the point of fatigue will produce an excess of lactic acid. But
just like when you run too long and you get stitches in your side?
Yeah, and lactic acid produces an imbalance in the electrons. It takes up some electrons to be formed, but in the process, that increases the alkalinity inside the cell, and in several ways creates a vicious circle of more electrons actually than it can take up. And one way that the cancer cell tries to return to normal is to use some of those excess electrons that can't be consumed by converting pyruvic acid to lactic acid, is to use them in synthesizing fat. So, interestingly, the cancer cell turns on the enzymes that synthesize fat as a way to drain away more electrons. And then, as oxygen becomes available, the respiratory process will burn fat. And so the cancer cell is eating all the sugar it can get and tearing down the tissue of the body to use amino acids in place of glucose when that's deficient, and converting the energy from glycolysis, either amino acids or glucose, converting that to fat, and then oxidizing the fat with whatever oxygen it has. And oxidizing fat is less efficient in terms of oxygen use, so it adds to the problem of oxygen deficiency.
Is this where the myth comes in, where you hear a lot of people say, oh, sugar feeds cancer?
Well, yeah, actually,
cancer eats sugar?
Sugar deprivation turns on the Warburg effect, turns on the stress reaction.
And makes the lactic acid and makes the cancer cells.
Yeah.
So it's actually the opposite, folks.
If you go into the ketosis, the stress metabolism that turns on this partial oxidation of fatty acids produces what they call the ketone bodies, but one of the ketone bodies is not a ketone, and it's the reduced state of this pairing of acetoacetate and beta-ketobutyrate, which is not a ketone. This is shifted so that it increases reductive imbalance. So it's almost as bad as lactate. So it's the stress that is creating this cycle of excess electron imbalance. And then that in turn activates things that can amplify, depending on the total situation, can amplify the stress reaction and the reductive excess of electrons. So that, for example, the formation of prostaglandins is turned on when there's a shift towards too many electrons, an imbalance in the direction of NADH rather than NAD, or of too much reduced sulfhydryl. People are talking, actually they're giving glutathione supplements to increase the electron abundance in the tissue, where the cancer cell already has an excess of electrons. It's a powerful antioxidant system that keeps the cancer cell alive, but in this defective state. And the same process that turns on prostaglandins, which create all kinds of inflammation and tendency to reproduce themselves without differentiating. It also turns on aromatase, which makes estrogen, which activates more of the tendency to produce excess electrons.
I picked up on what you said about 5 minutes ago, and I jotted a note down here just so I could ask you this, and this is definitely not scripted. But you mentioned the inability to relax, the over-excitation or the excitotoxic effect of various mediators that promote cancer, and how the cancer itself is in a very excited state, and this constant excitation, that oxygen, the presence of oxygen calms that excitation down. And this is the part that's unscripted. I wanted to ask you to understand this myself, because I know you're an advocate of CO2 and increasing your CO2 as a definite health benefit. And I know we've talked about oxygen being a poison, essentially, and I think that's not not a bad word for it. But so how is oxygen in this way being a help, as opposed to our general understanding of oxygen being a fairly toxic gas?
The CO2 does at least three central things related to the cancer. One, it's acting like a calming agent, the way ATP does to relax muscles that aren't stimulated, holding them in a state of readiness to contract. And the CO2 is an analog of these pigment molecules that Koch and Moses Gomberg were visualizing.
So you said CO2 has a structural similarity, because we haven't even talked about the anthocyanins and the flavonoids yet, but is that what you're saying?
Yeah, it's an acid, a Lewis acid, which doesn't involve any protons, but the double-bonded oxygens on the carbon are the essential feature of the free radical oxidative catalysts that Koch was talking about, and that St. George worked with for about 40 or 50 years. And this acidic effect modifies the proteins so that they are stabilized, calmed down, kept quiet, so that they aren't forced to shift over to the lactic acid metabolism. And the CO2 also can fill in and correct what's missing in the Krebs cycle, or the tricarboxylic acid cycle. It's replenishing the catalytic effect of the fuel that keeps the oxygen process going. And then CO2 also directly intervenes in the inhibition of lactic acid production. So just by increasing the CO2, breathing in a bag, for example, for a minute or so at a time, several times a day, will lower your serum lactic acid. And it's only in the last 2 or 3 years that several people are recognizing that you can diagnose cancer just by an increased chronic lactic acid excess in the blood. And since it's one of the factors that keeps the process going, anything you can do that will shift towards oxidative metabolism and lower your production of lactic acid is helpful.
That's why you recommend for people who have cancer that they go to high elevation so that they can increase the amount of CO2 in their bloodstream.
Yeah, there were studies in Russia in the 1960s in which they gave carcinogens to rats, and then they treated some with chemotherapy and took them to, I think it was 17,000 feet altitude, and the ones at high altitude recovered at a very high rate, with or without the chemotherapy. The chemotherapy cured a few of them at normal altitude, but cured most of them at the high altitude. And about 100 years ago, the insurance company industry was already aware that the cancer mortality was about 10% lower in cities at high altitudes. So it was well recognized.
Well recognized, because if anyone doesn't want to lose money, it's the insurance company. Well, thanks so much for explaining that. Let me just remind people again, it's a live show and callers are welcome to call in. I know Dr. Peat enjoys answering questions. The more outside the box, the better for him. I mean, I really appreciate your explanation of the CO2 effects and those three different mechanisms. And I promise you now, folks, that nothing was scripted here. That was just straight off the cuff. So really appreciate your input, Dr. Peat. A number if you live in the area. 923-3911, outside the area, 800 number, 800 KMUD RAD. If those people listening on the internet, I know that you can always communicate with KMUD via the internet as well. So, Dr. Peat, just talking about those energetic effects, and I wanted to ask you about the pigments, and we've already covered some of those. You mentioned a deep purple pigment that Moses Gomberg first discovered, or it got him thinking about the energetic state of pigments, and how I want to bring into this question the topic of flavonoids. And in herbs and in herbal medicine, I know that things like bilberry, very antioxidant. There's blackberries, the dark berry pigments, and we'll get into a couple of other specific herbs like pau de arco and the anthraquinone molecule in things like cascara and Chinese rhubarb and a few other plants that contain anthraquinones, and how they have. And I was only reading this afternoon on PubMed some articles based on those anthraquinones being proven to be anti-cancer or having an anti-cancer effect. So how do you understand? Because it's one thing for me just to quote PubMed articles and understand in my own limited way from my own limited education background of how pigments work in terms of how science, as I've been taught, understands it. But how do you think you see those pigments affecting that electronic change?
There have been several lines of research on emodin, which is the pigment in aloe and cascara and Chinese rhubarb, and it has a tremendous unexpected range of functions, including a somewhat sedative or quieting effect, definitely not a stimulant, but activating oxidative metabolism in cells, and having a bacteria-suppressing effect, and reducing inflammation. These are all properties that W.F. Koch saw in the simple quinone type of oxidative catalyst. Mm-hmm. And when Koch went to Brazil, he began studying lapacho. He was probably the one that made it famous, which is a similar structure, a multiple ring structure that has a deep color. What these are doing is the same as carbon dioxide. They're modifying, sort of tuning up the electrical system of proteins in cells. And that's the basic idea that I think has been a common theme from Warburg through St. Georgi, is that it's pointless to try to kill the cancer as if it was a parasite that could simply be removed, because it turns out that when cells are normally being fatigued and replaced, the dying cell stimulates the growth of stem cells to replace the tissue. And that's a process that happens in cancer. The natural cancer cell is very weak and defective, so it doesn't have a long lifespan. But every time it dies, it stimulates the replacement of a similar defective cell. And no matter how you kill the cancer cell, that area is injured and is tending to be replaced. The injury caused by killing it stimulates faster replacement in most situations than just leaving it alone. And the alternative idea is to tune up both the tumor metabolism as far as possible and the metabolism of the surrounding organism.
Let me pause you there a moment, Dr. Peat. I think we've got one or two callers on the line, so let's start taking this first caller. Caller, where are you from and what's your question?
Hi, I'm calling from San Jose.
San Jose, hi, what's your question?
My question is about the altitudes that Dr. Peat mentioned. Is there any other factor like the weather or something that influences it in addition to altitude? For example, let's say Denver versus Albuquerque, they have different weathers, but fairly similar altitude. Will both be beneficial, or is there something else also to look at?
Dr. Peat.
Was what beneficial?
The altitude. So he was saying, was there any other mileage in external factors like weather over the actual altitude that has a beneficial effect?
I think excess humidity is harmful because our osmotic balance is part of the process of tuning up. There's an interaction between oxidation reduction and pH and osmolarity, and all of the regulatory processes interact. And if you have very high humidity, it's a slight stress to the system. So middle range humidity is good, and as much daylight as possible. 15 hours of daylight seems to be optimal for recovery from cancer.
So being in the Andes would be a good idea. Not humid, closer to the equator, and high elevation.
So my question to you, Dr. Peat, then perhaps about humidity, is somewhere like Hawaii not a good idea? I mean, I know it's at sea level for a start, but maybe...
a volcano in Hawaii would...
Right. There you go. The top
Mauna Kea.
The top of Mauna Kea. All right, so humidity, you said, is a negative effect, has a negative effect, but outside that and daylight, the similar altitude will produce a similar benefit.
Yeah, I think so.
Okay, so I think we have another caller on the air. Hi, caller, you're on the air. Where are you from, and what's your question?
This is Jordan. I'm from Redway, and I wanted to ask Dr. Peat a two-part question. Dr. Peat, earlier you said that when cancer cells go from they survive on glucose, and then when they've used all the glucose, they go on to amino acids. I was wondering, are those the foods of choice for the cancer cells, or is it because they're so acidic, or is it because they're readily available? And then the second part of the question is, I've heard you say before that amino acids create a medium in the body that allows cancer to grow, and it's confused me because the amino acids are essential. So I just would like a little explanation on that.
It depends on what kind of amino acids. The cysteine, tryptophan, and methionine are the ones that most easily promote cancer growth and development, but glutamine and several of the easily metabolized amino acids are the ones that fuel the production of lactate, even when glucose is not available or is currently being depleted. So the stress that lactic acid reinforces turns on cortisol production and other stress signals that break down, shift the balance away from protein synthesis to protein breakdown, providing amino acids. Also, fatty acids come into the bloodstream under the same stress conditions. And if those are polyunsaturated, that adds to the prostaglandin inflammation promotion. And the stress hormones, cortisol, and the prostaglandins accelerate both the inflammation and the conversion of the tissues to food. There have been several types of experiments in which cancer growth can be slowed down by giving intravenous glucose. The Russian researcher who was he began working on the Pasteur effect, probably was aware of St. George's thinking in the 1940s. Some of his research involved giving good doses of glucose, either intravenously or orally. And with the use of intravenous glucose and higher provision of oxygen, the Ehrlich ascites carcinoma, he found, could be reverted to normal metabolism. The classical example of a cell that is in the Warburg effect of making too much lactic acid, giving it as much sugar and oxygen as possible, caused it to revert to normal metabolism.
Wow. Well, thank you, doctor. That's brilliant. Thank you so much.
Well, thank you for that.
And thank all the doctors. Thank you.
Okay, so I think we have another caller on the air, so let's take this next caller.
Actually, they just disappeared,
okay.
So hopefully they will call back in a second.
Okay,
Callers,
the number here,
back.
if you live in the area, is 923-3911, or if you're outside the area, it's an 800 number, 1-800-KMUD-RAD.
So, Dr. Peat, we've talked about carbon dioxide, high elevation being quite an anti-cancer therapy, and we've also talked about some antioxidants from like cherries and blueberries, bilberries, and the pau d'arco cascara. What are some other things that you would say are pretty anti-cancer and help with this respiratory
if you think of
process?
The process of stress between too much excitation and not enough energy, and just look at things that are known to reduce excitation. Anesthetics. Some of the common anesthetics will turn off the excitation enough to slow down cancer growth.
Have they done like injections of lidocaine or?
Yeah, lidocaine has been proven effective against several different cancers, leukemia and several solid tumors, I think liver, pancreas, and breast, prostate.
Can I hold you there? We do have another caller who I think maybe that caller's called back. So let's take this. Oh, the lights were flashing. You're telling me there's no caller?
No, it's a new caller.
Oh, okay, it's a new caller. Good. Okay, caller, you're on the air. What's your question? Where are you from?
Hello?
Hi, you're on there.
Hi, yeah. Now, do you advocate, let's say you have a lump that's just contained. It hasn't metastasized. Let's say it's a lump in your breast or somewhere else. That it's easily gotten to. Would you advocate surgically removing that lump so that it won't continue to be a time bomb and keep growing?
Dr. P, I can't imagine you would, but Dr. P?
If it depends on whole context. I've had lumps or things that doctors advised me to have biopsied, and I just changed what I was doing, and the problem went away. But if you aren't aware of anything that you can change, and if it, for example, if it's hard and stuck to surrounding tissues so that it seems definitely to be cancerous, then probably a lumpectomy is okay if you make sure that that you're taking precautions against activating a cancer by the surgery itself, which.
Well, what kind of precautions can you take?
For example, surgery's done when a woman is in the low progesterone part of the month before ovulation.
Right.
That is several times more likely to metastasize than in the presence of high progesterone. And I think all of the things that are known to reduce excitation, reduce lactic acid production, and increase oxidative metabolism. I think if all of those are done, then a lumpectomy is relatively safe.
Okay, we do have another caller, so let's keep moving here and get this next caller in. I'll give them a chance to ask their question. Call away from?
Hi, I'm in Albion, California. My question is around thyroid. It seems that it needs to be at optimal function. I recently went through about 5 years of really hard stress. I'm having fatigue. I have my thyroid levels drawn, which what they draw is TSH and free T4, which come back normal but on the low end. And I'm wondering if there's another test I could ask for, because I know if I increase a thyroid medication dose, it will change my life. But I'm wondering if we're looking at the right labs.
Okay, and there is one more caller after this, Dr. Peat, so...
I'm going to hang up. Thank you.
Okay, thank you.
I was going to say, ma'am, if you take your temperatures and pulses at specific times of the day and specific reference to eating, that's a much more accurate gauge for yourself to assess your thyroid function. And if you contact us, we can send you a form for free. So a form that you can fill out your temperatures and your pulses at different times of the day. And Dr. Peat, do you want to mention something?
Yeah. Go ahead. We've only got 5 minutes.
Yeah, the T3 is the essential active thyroid hormone, and under stress, T4 is converted to reverse T3, which interferes. So you can't at all interpret thyroid function with just T4 and TSH. And even T3 by itself, you have to consider how much stress is causing it to be converted to the inactive and blocking form. And so you want a good ratio of active T3 to reverse T3. And if you measure your cortisol, you can see usually what is causing it to be inactive. Sugar, glucose is needed to convert T4 to the active T3 form and to hold down the cortisol, which would inactivate the T3, convert T4 to reverse T3. So sugar is protective. Avoiding hypoxic conditions or inflammation that wastes oxygen locally. Any area that's deficient in oxygen or has an excess of lactic acid can locally destroy active T3.
I think I have to hold you there, Dr. Peat. I don't want to be rude, but we've got a couple of minutes just to close out some information here before we sign off at 8 o'clock. So thank you so much for your time.
And is there any one last thing you want to say, Dr. Peat?
Nope.
Okay, thank you so much, Dr. Peat. And
Okay.
I want to make sure I announce before we wrap up here that the Broadway Cinema is showing Vaxxed, or we're trying to get it to show Vaxxed. There's 2 showings that are potentially possible if people go online.
And what's Vaxxed about?
Well, I'm going to tell you that in a minute.
Good.
Well, actually, I should tell you. I'm trying to hurry up here. So Vaxxed is about a story of vaccination in families. There's a Facebook page.
And vaccine damage.
Yes, definitely.
Very much supporting that positive correlation between vaccines and damage.
And it's from Cover Up to Catastrophe. It's an investigation into how the CDC has covered up some information. There's a whistleblower. It's supposed to be a very interesting film. I'm hoping to see it when it comes to Broadway Cinema in Eureka, if it does. And you can visit the Facebook page. It's called Bring Vax to Humboldt. And you can go on to Gather, which is gathr.us/screening/16238. Probably easier just to go to the Facebook page, and then you can get information from there. So The two showings are August 10th at 7 p.m. and August 15th at 7 p.m. Try to sign up for the August 10th first so that we can actually get the film here. Otherwise, August 15th will be the second showing.
Thank you for all the callers that called in. We did have some more that we couldn't get on, and thanks so much for being there. I just want to let you know that next month we won't be doing the show, but we'll be back again in September. And it's my intention to carry this topic on through to next September, because we hardly had any chance to ask questions that I wanted to get Dr. Peat to answer. So thank you so much, Dr. Peat, for joining on the show. Until the third Friday of September, my name's Andrew Murray.
My name's Sarah Johannesson Murray, and we can be reached on 1-888-926-4372. That's 1-888-WBM-HERB.
Good night.
Good night.